450 million years ago, one creature witnessed life on Earth being wiped out in its entirety. Not once, but 5 times. Volcanoes erupted, burying entire continents beneath layers of ash. Asteroids slammed into the planet with a force billions of times greater than an atomic bomb. The oceans froze, then boiled. The sky remained shrouded in darkness for years, preventing sunlight from ever reaching the Earth's surface. Each time, most life on this planet vanished without a trace, leaving behind nothing but layers of sedimentary rock that preserved the silent record of a world that had died. The dinosaurs died, giant sharks died, trilobites, which had ruled the oceans for hundreds of millions of years, also died. 99% of every species that has ever existed on Earth has disappeared forever. Yet one tiny, silent, almost invisible creature survived, and it is still alive today. Deep beneath the ocean, it may be living only a few hundred kilometers away from you. What secret allowed it to become the ultimate survivor, while the strongest, the largest, and the most dominant creatures of every age were erased from existence? The answer lies deep within the mud on the ocean floor, and in the very way Earth redefined the meaning of the word strength. This creature has no fangs or claws. It has no speed. It has no intimidating size to frighten its enemies. At first glance, it is nothing more than a small animal with a hard, fan-shaped shell, hidden within the soft mud of the deep seafloor, where sunlight can scarcely reach. It is called a brachiopod, a marine animal with 2 shells that resembles a clam, yet actually belongs to an entirely different and far more ancient evolutionary lineage. Placed beside the most famous creatures in Earth's history, a Tyrannosaurus rex as tall as a 3-story building, a megalodon longer than a bus, or a trilobite protected by armor as hard as a medieval knight's suit, this creature appears almost insignificant. It does not hunt with speed. It does not defend itself with strength. It simply lies quietly on the seafloor, filtering food from the water flowing past, living a slow, unhurried life that has remained almost unchanged for hundreds of millions of years. Yet that very ordinariness is the key to one of the most extraordinary survival stories in the history of life. It was here before the first plants developed true leaves. It was here before any reptile took its first steps onto land. It was here before the supercontinent Pangaea formed, and it remained after Pangaea broke apart into the continents we know today. While nearly every other organism on this planet had to evolve, adapt, or disappear to make way for new forms of life, this creature has undergone remarkably little change in its overall appearance for 450 million years. Paleontologists have given it a fitting name, a living fossil. But to understand why that title is so astonishing, we must travel back through time, passing one by one through the catastrophes that nearly erased all life on Earth, and see how this tiny creature endured each of those nightmares. The first came approximately 444 million years ago, when Earth entered one of the coldest periods in its history. This was the Ordovician mass extinction, the first of the Big 5 mass extinction events ever recorded. At that time, nearly all life on Earth was still confined to the oceans. The land was a barren, desolate wasteland, with no plants, no 4-legged animals, and nothing capable of surviving on land except a few simple microorganisms. The oceans were the cradle of life, where every major chapter of evolution was unfolding. Then everything began to collapse. A massive ice age spread across much of the supercontinent Gondwana, locking away enormous volumes of seawater in ice sheets that were miles thick. Global sea levels dropped dramatically, causing the shallow seas, home to most marine life at the time, to shrink rapidly or disappear altogether. Ocean temperatures plummeted. Ocean currents shifted completely, disrupting food webs that had remained stable for millions of years. The result was catastrophic. Approximately 85% of all marine species disappeared forever. It is a staggering figure, especially when you remember that, at the time, the oceans were virtually the entire living world. Amid that first great mass extinction, the tiny brachiopod survived, not because of its strength, but because of the astonishing simplicity of its body structure and way of life. It did not depend on a complex ecosystem to survive. It did not rely on any particular prey to hunt. It simply needed seawater to flow past, carrying microscopic food particles that it could filter from the water. It was able to live at a wide range of depths, in different temperatures, and under vastly different environmental conditions, without having to change very much about itself. And that was only the first test. As it turned out, Earth had even more terrifying nightmares waiting. The second came approximately 375 million years ago, when a different kind of catastrophe began to unfold. This time, it was not a sudden shock, but a slow, relentless suffocation that lasted for millions of years. This was the late Devonian mass extinction. Unlike the Ordovician extinction, which was triggered by a global ice age, the late Devonian event is widely believed to have been driven by a dramatic decline in oxygen levels throughout the oceans. Scientists continue to debate its exact cause, but many hypotheses suggest that the rapid spread of plants across the land, one of the most significant evolutionary advances in Earth's history, ironically became the catalyst for a disaster beneath the sea. As plant root systems expanded, they fundamentally altered the way soil retained water and nutrients. Vast amounts of nutrients were washed into rivers and eventually carried into the oceans. This excess nutrient load fueled massive algal blooms, and when the algae died, their decomposition consumed nearly all of the dissolved oxygen in the surrounding water. As a result, vast areas of the oceans became dead zones, where almost no marine life could breathe or survive. Coral reefs, among the richest and most vibrant ecosystems of that era, collapsed almost completely. It would take tens of millions of years before reefs of comparable scale and diversity would recover. This was an especially dangerous kind of catastrophe, not because it struck with overwhelming force in a single moment, but because it persisted for millions of years, giving few organisms the opportunity to adapt quickly. It was like a chronic disease that slowly strangled life over an immense span of time rather than delivering a single fatal blow. Once again, our tiny brachiopod endured. Its simple body plan required remarkably little energy to sustain life. While many other species depended on abundant oxygen and high energy levels to swim, hunt, defend territory, or compete for resources, this tiny creature needed only to remain still, filter seawater, and wait. When an organism's metabolic rate is reduced to such an extraordinary minimum, it can survive conditions that would be impossible for species with far greater energy demands to endure. But everything this creature endured during the first two catastrophes was only a prelude to what lay ahead. The third came approximately 252 million years ago, when Earth entered the most terrifying chapter in its entire history. Scientists call it the Permian mass extinction, but the name it truly deserves is the Great Dying. This was not merely another mass extinction. It was the first true apocalypse the planet had experienced since complex life had emerged. Approximately 96% of all marine species and the vast majority of terrestrial species were wiped out completely. To grasp the scale of the devastation, imagine that out of every 100 species alive before the catastrophe, only about 4 survived. To this day, it remains the largest extinction event ever recorded in Earth's 4.5 billion year history, far surpassing the event that would later wipe out the dinosaurs. The disaster began in a region that is now Siberia. Over the course of hundreds of thousands of years, an immense chain of volcanic eruptions continued almost without interruption, creating one of the most terrifying geological phenomena ever known, the Siberian traps. These were not isolated eruptions, but an almost continuous outpouring of lava that lasted for an extraordinarily long time, releasing enough molten rock to blanket an entire modern-day continent. The enormous volume of gases released by these eruptions, including carbon dioxide and sulfur compounds, completely transformed Earth's atmosphere and oceans. Global temperatures soared. The oceans became severely acidified, preventing countless organisms with shells and skeletons made of calcium carbonate from forming and maintaining their protective structures. Dissolved oxygen levels throughout the oceans plummeted catastrophically. Acid rain devastated plant life on land. The ozone layer was severely depleted, allowing ultraviolet radiation from the sun to strike Earth's surface with an intensity never before experienced. This was a true apocalypse, not in the figurative sense, but in the most literal one. Nearly all complex life on Earth stood on the brink of complete annihilation. Scientists estimate that it took tens of millions of years for life to recover to a level of biodiversity comparable to what had existed before the catastrophe. Yet amid the greatest mass destruction in the planet's history, our tiny brachiopod quietly endured, resting beneath layers of sediment on the ocean floor, while the world above it collapsed. The fourth came approximately 201 million years ago, when Earth was once again shaken by the Triassic mass extinction. Compared with the catastrophic Permian extinction that preceded it, this event is less well known, but it was still devastating enough to wipe out approximately half of all species living on the planet at the time. Once again, the disaster was triggered by massive volcanic activity, this time as the supercontinent Pangaea began to break apart. Enormous quantities of carbon dioxide were released into the atmosphere, driving an intense greenhouse effect, acidifying the oceans, and once again disrupting Earth's global ecological balance. For our brachiopod, this had almost become a familiar story. It had survived this kind of catastrophe before, not just once, but 3 times. Its simple body structure, extraordinary tolerance for harsh environmental conditions, and low-energy lifestyle once again proved to be its greatest strengths. While many large reptilian lineages of the Triassic period were wiped out, clearing the way for the rise of the dinosaurs in the ages that followed, this tiny creature continued its quiet existence on the seafloor, almost entirely unaffected. By then, it had become a battle-hardened survivor, carrying with it the legacy of 4 victories over the most catastrophic disasters Earth had ever unleashed. But one final trial still lay ahead, a catastrophe that would become the most famous mass extinction event in history. The fifth came approximately 66 million years ago, when an object measuring roughly 10 to 15 kilometers in diameter struck Earth at a speed of tens of thousands of kilometers per hour, crashing into what is now the Yucatan Peninsula in Mexico. The impact created the Chicxulub crater, one of the clearest geological pieces of evidence for the catastrophe that brought the age of the dinosaurs to an end. The energy released by the impact was equivalent to the simultaneous detonation of billions of atomic bombs. A devastating shockwave swept across the region surrounding the impact site. incinerating everything within a radius of thousands of kilometers in a matter of minutes. Massive tsunamis, in some places reaching heights of hundreds of meters, devastated coastlines around the world. Enormous quantities of dust and debris were blasted into the atmosphere, blocking sunlight for years and triggering a global impact winter. Temperatures dropped dramatically, and photosynthesis nearly ceased across much of the planet. The rulers of Earth, for 150 million years, the non-avian dinosaurs, were wiped out in what, on the geological timescale, was an astonishingly brief period. Along with them, approximately 75% of all species on Earth disappeared forever, including many marine lineages that had dominated the oceans for tens of millions of years. Yet beneath the mud of the ocean floor, far from the epicenter of the catastrophe, our tiny brachiopod quietly carried on with its life. It had no way of knowing that, far above, the reign of the largest land animals ever to exist had come to a permanent end. To this humble creature, it was simply another trial, the fifth in a long succession of ordeals that it had faced and survived over the course of nearly 500 million years of existence. So, what truly enabled such a tiny, seemingly unremarkable creature to survive all 5 mass extinctions, while the strongest, most dominant species of every era were wiped out? The answer lies in a profound biological paradox, one that challenges our intuitive understanding of survival. We often assume that, in nature, the strongest, the fastest, and the largest will ultimately prevail. Yet the history of this planet tells a very different story. The first factor is the simplicity of its body plan. The brachiopod possesses an exceptionally simple body structure, free of the complex biological systems that are especially vulnerable when the environment changes abruptly. The more complex an organism's anatomy becomes, and the more specific the conditions it requires to survive, the more likely it is to collapse when even one of those conditions is disrupted. By contrast, a simple body has far fewer points of failure for a catastrophe to exploit. The second factor is its extraordinarily low metabolic rate. This creature requires very little energy to stay alive. During periods of crisis, when food and oxygen become scarce, organisms with minimal energy requirements have a far greater chance of survival than those with high metabolic demands. This is precisely why giant animals, which require enormous amounts of food each day to sustain their massive bodies, are often among the first casualties when food webs collapse. The third factor is its ability to thrive in a wide range of environments without depending on any single ecosystem. While many species can survive only within a narrow range of temperatures, water depths, or food sources, the brachiopod can tolerate a remarkable variety of conditions, from shallow coastal waters to the deep sea, and from warm oceans to cold ones. The fourth factor, and perhaps the one with the deepest philosophical significance, is that it never competed directly with the dominant species of its time. While giant animals were locked in constant struggles for territory, food, and ecological dominance, this tiny creature occupied its own quiet niche in nature. It attracted little attention, competed with virtually no one, and therefore was never among the first casualties when entire ecosystems began to collapse. While the strongest, the largest, and the most dominant creatures of every geological era disappeared one after another, the ultimate winner of the greatest survival contest in Earth's history turned out to be the humblest of them all. This is not a story about strength. It is a story about resilience, adaptability, and the realization that long-term survival does not always come from becoming greater, but from becoming so simple and so flexible that almost nothing can break you. Today, the descendants of those ancient brachiopods are still alive, although their numbers and diversity have declined dramatically from their peak hundreds of millions of years ago. They continue to inhabit the seafloor and oceans around the world, from shallow coastal waters to the deep sea. They have preserved the same simple lifestyle their ancestors maintained for nearly 500 million years, anchoring themselves to the seabed or burying themselves in marine sediments, filtering food from the passing water, and quietly existing, almost entirely removed from the violent changes unfolding in the world above. In today's marine ecosystems, brachiopods no longer occupy the dominant position their ancestors once held hundreds of millions of years ago, when they were among the most abundant and diverse groups of seafloor organisms on the planet. Yet their enduring presence remains a living reminder of a chapter in Earth's history that has lasted for nearly 500 million years, a chapter in which almost every other leading character left the stage long ago. Perhaps the most thought-provoking reality is that many scientists now believe Earth is entering its 6th mass extinction. This time, however, the driving force is neither volcanic eruptions nor asteroid impacts, but human activity itself. The current rate of species loss is estimated to be hundreds and possibly even thousands of times faster than the natural background rate of extinction. Climate change, ocean acidification, habitat destruction, and pollution are together placing unprecedented pressure on life across the planet in ways that are, in many respects, disturbingly similar to the forces that shaped the previous 5 mass extinction events. The question is this: can a creature that has already survived 5 mass extinctions, a creature carrying nearly 500 million years of experience, enduring the harshest conditions this planet has ever produced, survive a 6th? Or will this time be different? When the force driving the catastrophe is no longer nature itself but another living species, will the survival strategies that sustained it for 450 million years still be enough to protect it? No one knows the answer with certainty. But the story of this tiny, humble creature, which has silently witnessed and survived every major catastrophe in the history of life on Earth, leaves us with a profound lesson. Sometimes, survival does not belong to the strongest or the most dominant. It belongs to those that know how to endure with humility, adaptability, and unwavering resilience through every change that time brings. Which species alive today do you think is most likely to survive if the sixth mass extinction truly unfolds? Share your thoughts in the comments.